In this presentation I will tell you what is vectors addition. So here if we have two vectors u and v, in order to add vector v to vector u, we have to move vector v so its tail coincides with the head of vector u, and the vector whose tail is the tail of vector u, and the head is the head of vector v, is the sum of vectors u and v. Here is the sum of the two vectors. You can notice that the position of vector u on the result of the sum u plus v does not matter. So we can, for example, place a vector u at the origin. Now we can add vector v, and as a result we'll have a vector which is the sum of u plus v, and it is exactly as the same as the result before. They are the same. So here once again the position of vector u does not matter as long as the vectors are equal. Here the sum of the two vectors are also equal. So here let's move it back to its place. Now let's investigate what will happen if we add vectors u and v, but we'll add u to vector v, so we'll change the order of the addition. Here, and you can see that the result is the same. U plus v is the same as v plus u. So here we have now v plus u, and we have this property of vector addition: u plus v is the same as v plus u. Now let's try to explain it more mathematically, and let's build a parallelogram on vectors u and v. Okay, here is one more side of the parallelogram and the last side of the parallelogram. You can notice that vector AB is the same as vector MN, and vector BN is the same as equal to vector AM. So this explains why vector addition is commutative. means that we can switch the order of addition and we'll get the same result. We can move this vector here, we'll move this vector here, and the result u plus v is the same as v plus u. Okay. This property of vector addition we call commutative law.